In the years of watching Billy run our electricity and plasma lab, two things have become abundantly clear. Oscillatory patterns are ubiquitous when you're dealing with electromagnetism, and there are two different kinds of important electromagnetic events: peak magnetism and polarity reversal. In many ways, the difference between -1 and +1 is as great as the difference between 1 and 1,000. It's where the force changes direction. So I suppose it should not have been surprising when we saw a pattern connecting peaks in magnetism and polarity reversals among the grand solar polar fields with the largest earthquakes on the planet. Nor should it be surprising now that it has been confirmed by third parties and further observations. This video summarizes 5 years of observations and research. Thus far, the data suggests there is a relationship between the sun's magnetic fields and the largest earthquakes. Let's go back to New Year's Day, 2014, when this all started. We have multiple videos showing that the biggest earthquakes since a number of solar anomalies in 2007 and 2008 have all been correlated with coronal hole activity, and we are not the only ones showing it. This is way old news. But if we're going to use coronal holes, solar wind power, blocking fields above, well then we should look here as well. Let me overlay those last 10 8 magnitude earthquakes or bigger, and if you use the Stanford site I showed you yesterday, you'll see how darn incredible this is. After looking through the entire data set back into the 1970s, we had to get the professionals involved. Living in Columbus, Ohio at that time, I went to the Ohio State University Statistics Department, where the professors and select grad students ran a statistical consulting service. A few months later, they had mathematically shown that pattern to be true, and we collaborated to publish a paper. Dr. Kongpa Buyen contributed to the paper, and Dr. Holloman represented the Ohio State group. Here's the scoop. Due to Earth's orbit tilting slightly versus the solar equator, we're closer to one pole 6 months out of the year, and then the other. We see that up top, and it presents as a peak in solar polar field strength every 6 months opposite the other. Approximately every 11 years, these fields reverse as the sun goes into sunspot maximum, and the process takes place with 6-month alternation of polar field strength, but with the opposite polarity at each pole. The first paper looked at data from 1976, the start of operation of the Wilcox Solar Observatory data, and continued through the end of 2013. Blue curve is the northern fields, red is the south, and you can see both the alternating strength each cycle and the 11-year cycle of reversing polarity. The yellow line is the average of the two, and this is important because our latest study tweaked that a bit. We were also able to separate the polar field cycle into segments: polar minimum, polar recovery, and polar maximum. Polar minimum may be considered polar reversal as well, since that is what's causing the minimum strength of the fields. It appears the nice sine wave pattern usually doesn't return through polar minimum and polar recovery till 18 months thereafter, and we're in polar maximum, which of course is sunspot minimum. The paper demonstrated statistically that the peaks in magnetism and reversals of magnetism of the individual polar fields and the reversals of the average solar polar fields of the sun were closely tied to the largest earthquakes on the planet. When we started, the goal was to try to use the polar fields to eliminate half the days as not being tied to those significant polar field events to see if we could get far more than 50% of the largest earthquakes in that window. We ended up excluding nearly 60%, meaning that if there was no correlation between the solar polar fields and the largest earthquakes, we'd expect to see about 41% of those largest earthquakes in the time period. But instead, just under 80% of the largest earthquakes appear to occur close enough to significant solar polar field events to drive a very high confidence, in excess of 99.99%, that this pattern is not random. The paper describes how we envision the mechanism of triggering seismic pressure would work. Statistical jargon can be found in the appendices. The paper is also meant to be an introduction and Cliff's Notes to the entire current knowledge regarding electromagnetism and electrostatic forces and precursors involved with major seismic events. An important point that needed to be made was done so at the end. The coming solar cycles are not expected to look normal by everyone. In fact,
Many believe the sunspot cycle will change drastically over the coming years, and that it may already be presenting in this current week cycle. The northern polar fields of the sun appear anemic, and neither is really showing a nice sinusoidal pattern like we're used to seeing. The recent polar minimum and magnetic reversal of the sun took longer than any other on record, and it is taking a while to get in gear afterwards. This is important to keep in mind for later. We've hypothesized about just how these solar polar fields might interact with Earth. Most of the internal discussions here at Space Weather News involved either their modulation of the heliospheric current sheet and solar wind, or Earth's movement through sector boundaries in different portions of the fold. However, since 2011 we've also been watching coronal holes and noticing a similar pattern with earthquakes there. The ability of the interplanetary magnetic fields from coronal holes to affect Earth is evidenced in their speedy solar wind streams, in the magnetic connections and flux events between Earth and Sun, and all of that is contained within the current sheet surrounded by the polar fields, potentially meaning they have a better shot at affecting Earth. This is important for our second paper from last year. It involved an examination of the same fields as before, but included those from coronal holes via solar wind speed monitoring. During the largest earthquake of 2015, the Chile 8.3 on September 16th, the solar polar fields and corresponding lower latitude fields associated with the coronal hole that contained the polar fields had a brief surge in power. Let's look at the solar wind speed of the entire sun flattened out to a rectangle here. Left side faces Earth, right side is the far side of the sun, and we're going to look at the days leading up to that big quake and then 2 days afterwards. Top right is earthquake day. The red patch that grows to that day and then recedes is a brief surge in the solar wind, implying stronger magnetic fields as well. But this event took place over less than a week, so how would it be captured in the 10-day average solar polar fields data we used from Stanford for the first paper? It can't, meaning that until we get more data on the solar polar fields, we need a way to see shorter term, for example, using the solar wind speed. The fields that surged belong to the coronal hole here, massive with an Earth-facing transequatorial extension. The solar polar fields are measured at the Earth-facing 55th latitude of the Sun, but if those are surging in strength, why would that surge in power stop at the 55th latitude? It shouldn't, and in all likelihood, we need to be monitoring the force of these coronal holes as well. That's a major focus of our latest work, but first, let's summarize. Years of watching the sun every day revealed a pattern that professional statisticians then proved existed mathematically. However, we were not finished yet. We need to see how this model holds up into the future, especially in light of a potentially changing polar field cycle that we discussed a bit ago. It's not going to look like it has in the past. Well, now we come to the latest update. We've watched for 2 more years and can now look at the patterns of solar polar field cycle continuing to change, along with our understanding of the cycle segments, polar minimum, recovery, and maximum. And yet, despite the changes, many of the previously observed patterns appear as solid as ever. We're going to take a look at coronal holes as well and more inferred surges in field power from extreme solar wind changes, starting with some of those from our first papers. 5 magnitude 8 earthquakes in a row, including 2 at that line on the same day in April 2012, occurring suspiciously close to peaks in positive magnetism of the southern solar polar fields in red and the combined solar polar fields in yellow. Last time we averaged the 2 for the yellow line. This time we simply added them together. We're mostly focusing on events during the tenure of the SDO, but we did go back and show the hard-to-see coronal hole down south on Soho from the day an 8.8 struck Chile on February 27, 2010. The southern solar polar fields that were peaking belong to that southern coronal hole. On March 11, 2011, magnitude 9 earthquake struck Japan, and the southern peaking solar polar fields belong to that southern great dark patch reaching up to Earth-facing longitudes on that day. Twin 8-pointer struck Sumatra April 11, 2012. The northern field's extension is most visible as a fish-shaped dark patch, but the southern fields are actually extending up just to the left of it, hidden by coronal material. Another example of coronal holes, big ones, on Quake Day. Next was the 8.0 in the Solomon Islands, February 6, 2013. Peaking southern polar fields belong to that southern coronal hole. Then, the magnetic reversals began. May 24, 2013, polar minimum kicked off as the southern polar fields in red had their only reversal of the entire solar cycle during the time of the earthquake. And yet, we also had another instance of massive coronal hole structures facing Earth during major quakes. The coronal hole here, as you can see down below, presented an extreme change in solar wind with that sliver of red. But look at the powerful southern fields extending up to the equator there on the left side as well. When you look back up at the coronal holes in pink, you can see there's a southern hole there too. It's just harder to see. Then we come to the magnitude 8.2 in Chile on April 2nd, 2014. Here's where it gets a little interesting. It absolutely had both northern and southern polar coronal hole extensions reaching for the equator, but it also occurred at a point we had previously considered to be significant. In our first paper, we had both start and end of polar minimum as being significant for earthquakes, but we originally didn't know whether to use the last reversal of the cycle or the separation of the north and south curves as the signification of that moment. We ended up going with the former last year, but this earthquake occurred on the last day the curves crossed one last time before breaking into this next polar field cycle. It's the option we opted to ignore in our first paper. That was the only 8-pointer that year, but a 7.9 struck Alaska on June 23rd. This occurred at what we call mini peaks with a reversal. We eventually excluded those from our first analysis last year as well. Despite the obvious dark coronal hole in the middle, you should also notice both north and south intruding lower. There are definite darker areas, top and bottom, pinching towards the equator, yet again on quake day. When we look at the polar fields during that time, we find a brief and somewhat moderate spike in combined negative magnetism of our star in yellow, as the blue northern fields goes down as well. But while it is only moderate in terms of intensity, likely due to the overall weakness of the sun's polar fields right now, we can pull back and realize that this spike represented the strongest negative magnetism our star has presented to Earth in more than 5 years, all while the northern fields couldn't pick a side, kept reversing polarity. We also saw a strong surge in solar wind speed during this quake. The southern fields on the left side are powerful in red, but watch how the red appears and grows up through earthquake day. That type of short-term surge in power cannot be captured in 10-day average solar polar fields data like we get from Stanford. Then we come to 2015, and we decided to include all 7.5 magnitude earthquakes and above. 6 of them you see here. There are 2 at the green line actually, when twin 7.6 earthquakes struck Peru and Brazil on the same day. Left to right, we've got 7.5s in Papua New Guinea in both March and early May, positive northern field peaks. Then we've got a southern negative peak down below, 7.8 in Japan, that actually registered 8.6 by one seismologist, with many others coming in above 8.0. Black line top right is the 7.8 that struck Afghanistan in October, and again we had 2 quakes at the green line. That's 3 big ones tied to that double northern peak, just like the quakes we saw tied to the northern peak 6 months earlier. 6 of 8 great earthquakes of 2015 are astounding matches within days, and no longer than 11 days after these once or twice a year solar polar fields events. The other 2 great earthquakes of 2015 can be seen here. One on the right side is the Chile 8.3 from September 16th, the one we discussed in the second paper from last year, and the one that showed us that sometimes the solar polar field 10-day averages are not going to capture a surge in solar polar field force over shorter time periods, and certainly are not going to detect them in coronal hole magnetic fields or planetary magnetic connections. The line on the left, well, that's the one that has us scratching our heads a bit and realizing this model still can't teach us about every major quake. The Nepal disaster of 2015, the most deadly of the year, showed nothing but Earth-facing coronal holes. We'd expect those since every other major quake has them, but we saw nothing in the solar polar fields or solar wind speed data to suggest this event was like all the others. In the appendices of our latest release, we have this chart showing every major quake you heard about today, plus other huge ones going back a few years. 2 things are readily apparent. First, not every quake is going to fit into our patterns, and second, a lot of these earthquakes are tied to solar polar fields events that are separated by dozens to hundreds of days, and in some cases, years. And yet so many of the earthquakes are within 2 weeks of the significant polar field events, and let's be honest, many are much, much closer in proximity than that. certainly not to be ignored. Of course, that is readily apparent just by looking at this chart where we started, and of course I welcome you all to do your own homework going through the past events and seeing how well they all work throughout the entire 40-year period of solar polar fields data. It is important to note that accuracy of the models drops when you get down to about magnitude 7, as it seems the Earth just needs a little bit of help to make the biggest quakes and produces all the smaller ones on its own. So where do we go from here? Well, on a micro level, a few weeks from now we're going to be able to tell you if the spike we're currently seeing in negative and combined magnetism from early March was indeed a longer-term spike, in which case the first major quake of 2016 will be added to the list as well, the 7.8 that struck Sumatra. But speaking from a more macro level, where we go from here must involve better men than I. At this point, we are going to continue to verify as time goes on, but with observations confirmed by statisticians, confirmed by more observations, we're starting to get pretty confident, and I'm going to have to start asking someone at Stanford or NASA or NOAA or some university, please, write a paper or an article or make a comment or something that helps the world figure this out a bit better. To say this is beyond obvious and needs to be commented on would not be the most untrue thing you hear today. In the interest of science, can anyone in a good position have the guts to take this handoff from an amateur and get the field where it belongs? Trust me, I'm happy just sitting here watching SDO every day and waiting for the grid to go down. 3 significant air travel disruptions in the last year during strong geomagnetic activity. I'd love a comment on that one too. As always, we've got our eyes on all of this, everything between these spheres and a lot more. Eyes open, no fear. Be safe, everyone.